Hello everyone. In this video, we will do miscellaneous exercise inverse trigonometric function.
Yes, we are doing miscellaneous exercise on chapter 2 NCERT Inverse Trigonometric Function. Whatever question I am leaving, that question will be your homework. You have to do it by yourself. If you find problem on those questions, you can comment. I will solve it for you. Thank you. Now see question number 1. Find the value of cos inverse cos 13 pi by 6. We can write this 13 pi by 6 as 2 pi plus pi by 6. 6 2s are 12 plus 1 13. So 2 pi plus pi by 6 we can write cos pi by 6, because cos 2 pi plus theta is cos theta. This is the rule which we have studied before. Now from this we can find cos inverse cos pi by 6, and we can write in place of this, according to this rule, cos inverse cos x is equals to x, because if x belongs to 0 to pi, and we are getting x as pi by 6, which is between 0 to pi. So this is the answer. Hope you understood this question. Now see question number 3. Question number 2 is for you. Question number 3 says, prove that 2 sin inverse 3 by 5 is equals to tan inverse 24 by 7. Now we'll start from sin inverse 3 by 5. I can write sin 3 by 5 as a, so sin a will be 3 by 5. Now I'm making a right angle triangle. In that triangle, according to sin a 3 by 5, this 3 is perpendicular and this 5 is hypotenuse. 3 and 5. So base will be 4 according to Pythagoras theorem. Now tan a will be 3 by 4 perpendicular upon base. So a will be tan inverse 3 by 4. Now if we take LHS, left hand side of this, 2 sin inverse 3 by 5, I can write 2 sin inverse 3 by 5 as 2 tan inverse 3 by 4. And there is another rule, 2 tan inverse x is equals to tan inverse 2x upon 1 minus x square. We can use this as formula here, tan inverse 2 into 3 by 4 upon 1 minus 3 by 4 whole square. If you simplify this, you will easily get tan inverse 24 by 7. So hence proved. This was to prove. Now see question number 4. Question number 4 says, prove sin inverse 8 by 17 is equals to sin inverse 3 by 5 equal to tan inverse 77 upon 36. We have to prove that LHS is equals to this RHS. Now LHS is starting from LHS, sin inverse 8 by 17, we can write tan inverse 8 by 15 by using, again, making a right angle triangle and using the same property which we have applied in question number 3. And sin inverse 3 by 5, I can write tan inverse 3 by 4. I got this value in previous question. Now tan inverse x plus tan inverse y, we can say tan inverse x plus y upon 1 minus xy. This formula I am applying here, x plus y upon 1 minus xy, tan inverse. So 8 by 15 plus 3 by 4. So if I take LCM, 8 4s are 32 plus 45 upon 15 4s are 60, and here also I will get 15 into 460 as LCM. So 15 4 is 60 minus 24. If I simplify this again, I'll be getting tan inverse 77 upon 36. This is RHS, hence proved. Now question number 9. Prove that tan inverse root x equal to 1 by 2 cos inverse 1 minus x upon 1 plus x, where x belongs to 0 to 1. Here I am assuming that x as tan square a. X as tan square a, I am replacing it in right hand side part, this one, the bigger part. So 1 by 2 cos inverse 1 minus tan square a upon 1 plus tan square a. Now we know the rule 1 minus tan square a upon 1 plus tan square a is cos 2a. If I will replace the value of this by cos 2a, 1 by 2 cos inverse cos 2a, this will be cancelled out, then 1 by 2, this 2 will be cancelled out with this, and here also we have this 2, this must not be here, so tan inverse root x, that was to prove. This is very important question, question number 10, which we are going to start. Prove that cot inverse root 1 plus sin x plus root 1 minus sin x upon root 1 plus sin x minus root 1 minus sin x is equals to x by 2, which we have to prove. Now a little thing which we have studied in class 11th, I have explained you in the classroom, that still I am explaining you once again. 1 plus sin x or 1 minus sin x, you can write it in this way. 1 you can write cos square x by 2 plus sin square x by 2 in place of 1. If angle is same, I can write anything in term of square of sin and cos. So I am taking x by 2 here because it is requirement of the question. And plus minus, because plus minus I have written here. In place of sin x I can write 2 sin x by 2 cos x by 2. That is a half angle formula which we have used in this chapter once previously. Now I can write cos x by 2 plus minus sin x by 2 whole square. A plus b whole square, a minus b whole square, taking any of the sign. Now LHS cot inverse root cos x by 2 plus sin x by 2 whole square plus root cos x by 2 minus sin x by 2 whole square, because it is 1 minus sin x, that's why this one, 1 plus sin x, that's why it is plus 1 here, plus 1 apart here. 1 plus sin x cos x by 2 plus sin x by 2 whole square root में minus root cos x by 2 minus sin x by 2 whole square. Now there is one more rule, root x square is mod x. So root cos x by 2 plus sin x by 2, I can say root x by 2 plus sin x by 2. Similarly, modulus cos x by 2 minus sin x by 2 upon modulus cos x by 2 plus sin x by 2 minus modulus cos x by 2 minus sin x by 2. Cot inverse. Now we know that this part is positive, so there is no issue. You can write it cos x by 2 plus sin x by 2. This is also positive, so cos x by 2 plus sin x by 2, no issue at all. You can write it directly. But for this we have to think a little. We know the value they have given x between 0 to pi by 4. It means cos x by 2 greater sin x by 2. According to the graph of sin and cos, 0 to pi by 4, 0 to 45 degree angle, cos is always greater than sin. So cos x by 2 minus sin x by 2 will be greater than 0, means it will be a positive value. So modulus will remain positive. So cos x by 2 minus sin x by 2 would be plus cos, same this one. Here also it will be positive only, so because of that minus sign will be multiplied inside, so cos x by 2 plus sin x by 2 minus minus plus. So sin x by 2 will be cancelled with this minus sin x by 2, cos x by 2, cos x by 2, 2 cos x by 2, cos x by 2 minus cos x by 2 cancelled, sin x by 2, sin x by 2 will be added to sin x by 2, cos upon sin, cot inverse cot x by 2 will give you x by 2 only. This is the part which we need to prove, hence proved. Now question number 11. This is also very important one. Prove that tan inverse root 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x is equals to pi by 4 minus 1 by 2 cos inverse x. Here I can say x is cot 2 theta. I put the value. So x is cot x 2 theta. Then tan inverse, I'm taking LHS first. Tan inverse root 1 plus cos 2 theta minus root 1 minus cos 2 theta upon root 1 plus cos 2 theta plus root 1 minus cos 2 theta. 1 plus cos 2 theta will be 2 cos square theta, and here also 2 sin square theta. 1 minus cos 2 theta. This is the rule I have written here, the formula which we have studied in class 11th. I just put formula in all 4 places. Root 2 will take common and will cancel out. Root cos square theta will give you only cos theta, and root sin square theta sin theta. Similarly this one. Now if I divide numerator and denominator by cos theta, then this will be 1, sin upon cos will 10, 1 minus tan theta, 1 plus tan theta. Similarly tan inverse tan pi by 4 minus theta, this 1 minus tan theta I can say 1 minus tan theta, in place of 1 I am writing tan pi by 4 minus tan theta, and 1 plus tan theta I can write 1 plus tan pi by 4 into tan theta, because tan pi by 4 is 1, so 1 I can multiply with any number. Now why I have written in this way, so that I can create formula tan a minus b, tan pi by 4 minus theta. Now in place of 1 minus tan theta upon 1 plus tan theta, we can write tan pi by 4 minus theta, then it will be cancelled out. Pi by 4 minus theta will be the answer. Now theta, in place of theta we can write 1 by 2 cos inverse x. Why? First this cos will go other side, so cos inverse x equal to 2 theta. Then theta will be 1 by 2 cos inverse x. Note it. Now in place of theta 1 by 2 cos inverse x, which was to proved. Right hand side. Now we are doing one more question. This question is very simple, and you can see also the solution is very short even. Prove that 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 equal to 9 by 4 sin inverse 2 root 2 by 3. Now what I can do here, I can take 9 by 4 common. 9 by 4, if I take common, it will remain pi by 2 minus sin inverse 1 by 3. Now this pi by 2 minus sin inverse 1 by 3 I can write in place cos inverse 1 by 3 according to the formula. Sin inverse x plus cos inverse x equals to pi by 2. That formula I am applying here. So cos inverse 1 by 3, this 1 by 3 I can write in that way, in right angle triangle once again. Then base is 1, hypotenuse is 3, then perpendicular will be 9 minus 1 under root 8. 2 root 2 it means. So 19 by 4 sine inverse 2 root 2 upon 3 perpendicular upon hypotenuse 2 root 2 upon 3. That was to prove, hence proved. Very simple one.
Thank you for watching.